Welcome friends. In this video, we are going to see applications of Laplace transform, especially to solve differential equations. Question definitely asked for 5 marks. Okay, so first of all, I will give basic of applications and then we will solve examples. Okay. This is what is the basic. First formula Laplace of derivative first order and Laplace of derivative of second order. So this formula you must know and then we can try examples. Suppose you are given these conditions. You are given y at 0 is 1 and y dash at 0 is equal to 2. These conditions are always given to you. These conditions are known as initial boundary conditions. Initial boundary conditions. Okay. So, initial value problem is given. Solution. So, y double dash minus 4y. First of all, we write example as it is. And then take Laplace on both sides. Ly double dash minus 4y is equal to 0 because Laplace of 0 is 0. So here Laplace of y double dash minus 4 L of y is equal to 0. Okay, or here we may write L of 0. L of 0 is 0. So this Ly double dash, now f double dash is compared with y double dash. Therefore, here we write s square into y at s, that is Laplace of y at t. Or we may write Laplace of y. Then minus, I am writing this phi s. Phi s means Laplace of y. Minus s, that is this. And here f of 0. But f of 0 is nothing but y at 0. Then y f dash, that means y dash. So we have completed this. Now this is left. Therefore we continue. When y is equal to 0. Right? See, solve the differential equation. You are given conditions as it is. Take Laplace. Then use formula and get this. Now use these conditions, y at 0 and y dash at 0. So s square into ly as it is. We may take ly common. See. So we get a square minus 4 and then multiply by ly minus. Now if you put y of 0 is equal to 1, then I have to add yes. If y dash 0 is 2, then I subtract this and it is 0. So again, ly we can take common. There would be s square minus 4 and then remaining two things. Okay, sure. We have to calculate, solve the differential equation. That means we have to find out value of y. So this is y, this is L, this is Laplace transform. So we simplify this. Therefore, Laplace of y equals to. Now I can imagine this minus s goes there, it becomes plus. I can imagine this minus 2 goes there, plus 2. And then this is shifted. So if you make multiplication, therefore we get s square plus s square minus 4. So in this way we can simplify. But we want y. What do you mean by solve the differential equation? That means we have to find out dependent variable y. So in y, this y can be written as s plus 2 and here s square minus 4. So which is same as we write in standard form. So yes is only s square minus 4 and then directly we shift this 2 we can take out, or we may write inside the bracket plus here minus into bracket 2 divided by s square minus 4. So So y is equal to, this is standard formula for cos into bracket 2b, plus this is standard formula for sin 2b, and this is the answer. So you are having this answer for differential equation. So what is the basic? Basic is this. You must know these properties. Now try to understand. F dash means y dash. F double dash means y double dash. So you can solve like this. So this is what is the method of solving differential equations by using Laplace transform. Okay. One more question we are going to solve by this method. Okay. Suppose you are given little big differential equation, then how to solve? So let me consider the equation. Example. Solve the differential equation y triple dash plus y double dash is equal to e to the power t plus 2 plus 1 with initial conditions. Now what are the initial conditions? Initial conditions are given in single line. See method of writing. That means this is 0, this is 0, this is also 0. Okay, so we have to solve. Now we can solve the differential equation by Laplace transform. So first of all we take Laplace on both sides. Given y triple dash plus y double is equal to s to t plus t plus 1. So Laplace of y double triple plus L of y double and plus Laplace of e raised to t, this one, plus Laplace of t and plus Laplace of 1. So everywhere I am writing Laplace. By using linearity property we can separate addition like this. So we get triple dash, now here double dash. So what is the formula for triple? So that formula starts with s cube, because the double dash 2, single dash yes, triple dash cube, it is multiplied by 5s minus s square yes, therefore 1 degree less, and f of 0, then 1 degree less, and f dash 0, then minus of double dash 0. This is the formula. Okay. Therefore, this can be written as s cube into L of 1 means 5s minus s square, y of 0 minus s, y dash of 0 minus y double dash 0. Okay, this complete bracket is nothing but this. Now plus L y double dash, you can use this 5s. Remember, 5s means L of y. So s square into Laplace of y minus s, f of 0, but we write y of 0 here minus y dash of 0. This is complete value for this, and now is equal to, now right hand side. Laplace of s to t is 1 upon s minus 1, right? Laplace of t 1 upon s square, and Laplace of 1 is 1 by s. See, in applications we are required formulae for Laplace as well as inverse Laplace. Now there is one magic. See, everything is 0. Therefore, we write L by common, here s cube remains, then go further, everything is 0, this is 0, this is 0, this is 0, this comes. So plus s square, Ly is taken common, so don't repeat. Okay, this is 0, this is 0, so we write equal to 1 upon s minus 1, then plus 1 upon s square and plus 1 upon s. Now we have to find out y. So here y is equal to, here we write 1 upon s minus 1, this can be simplified further. So here we can take common s into bracket, sorry, s square common, s plus 1, and here we simplify this. Simplification of this comes s square into bracket s minus 1. So here s minus 1 is already there, so we here multiply by s square is there. then we multiply by s minus 1, and you know this, plus s into s minus 1. So this is what is LCM method. Let me erase this and then proceed further. So you have 1 into s square into bracket s plus 1, which is equal. Now we can simplify this. S square plus s minus 1 plus s square minus s and divided by s square into s minus 1. So this s will cut. Okay. And what we get is s square plus s square 2s square and then minus 1 and divided by s square into bracket s minus 1. Okay. Therefore, L of 1 can be written as 2s square minus 1 divided by s square. Then here s minus 1 and here s plus 1. Okay, and s square is there. So s square into s square becomes s raised to 4. Let me check. Yes. So what is y? So this is a big question. And inverse into bracket twice s square minus 1 divided by s raised to 4 into s minus 1 into s plus 1. And now we can solve by partial fractions. That is very important. Partial fractions. Because there is no standard formula of writing the inverse Laplace of this. Partial fraction method. So what is partial fraction method? So partial fraction method means 2 s square minus 1 divided by s raised to 4 into bracket s minus 1 s plus 1 can be written as. This is repeated factor, this is linear factor, this is linear factor. So we can write a divided by c. S is repeated 4 times, so we will write s b square. आता काय करायचं 4 ऍडजस्ट करायचं. ओके, so we write q and d upon s. So you have to stop. So this is what is method of repeated factors, repeated linear factors. S is linear, but it is repeated 4 times. So ABCD comes. Now s minus 1 different. So different is e upon s minus 1. Then s plus 1 is different. F s plus 1. So this problem is very important. Okay. Now ABCDEF we have to find out. So what is the method of finding ABCDEF? A is multiplied by. Now you can observe that A S. Okay. So what is the denominator? Denominator is this. So already s is there. So here you can write s cube into s minus 1 and s plus b. S square is there. See, if s square is there, then what we to write is s minus 1 into s plus 1. Then plus c. Now if cube is there, then what is the balance? S. So s minus 1 into s plus 1 plus s4 d. So s4 I erase this. We are getting 2 factors s minus 1 and s plus 1. Then e. Observe e. S minus 1 is there. So don't repeat this. So we write s raised to 4 into s plus 1 and last f. See this s plus 1 is there. So don't repeat this. We take s raised to 4 into s minus 1. This is very clear. Now ABCDEF we have to find out. And at once we get ABCDEF, we are through. See how to find out ABCDEF. First what we will do is put s is equal to 0 because it is there. If it is 0, then s square, s cube, s4 becomes 0. So put s is equal to 0 in this expression. On left hand side we get minus 1. See, if it is 0, minus 1 is equal to. This is 0, 0, 0. This is not 0, this is 0, this is 0. So D is left. So D into bracket 0 minus 1 and 0 plus 1. So minus 1 is equal to minus D. Okay. And therefore D is equal to 1. So let me repeat once again. If I say 0, A, B, C, E, F, not this right, just D. 0 minus 1 and 0 plus 1 comes minus, and minus 1 is plus, D is equal to 1. Then we can select next value of S. This is just minus 1. S minus 1 vanishes if we put S is equal to 1. Now, again imagine, if S is 1, what happens for left as well as right? See, left hand side, if S is minus 1 or 1, then 1 square is 1 and 2 minus 1 is 1. So, I will write this one as it is. A will go because 1 minus 1, 0, 1 minus 1, 0, 0, 0, 0. So, I will write A only. So, E into bracket. Now, S raised to 4, that means 1 raised to 4 is 1 and 1 plus 1, that means 2. And therefore, E is equal to 1 by 2. Finish. So, this one is how? Again, I can select. There is chance of selecting next value. Yes, S plus 1, this one will vanish. Okay, if S is equal to minus 1. If I put minus 1 on the left, then I am getting minus 1 square is 1. 2 into 1 is 2, 2 minus 1 is 1. So you can observe that again left hand side is 1. And I will not write S, sorry, A, B, because minus 1 plus 1 cut, minus 1 plus 1 cut, A, B, C, D, E. Also I cannot write, and F is left. So then I write F into, this is actually multiplication. Okay. So F into S is minus 1 is to 4 is plus 1. And here minus 1, minus 1, minus 2. And what is F? Minus 1 by 2. This is. So you are getting 3 values. E, D, E, F. Okay. So what are the remaining things? A, we have to find out. B, we have to find out. And C, we have to find out. So how to find out A, B, C again? Here we can write 2s square minus 1 is equal to. Here we observe that s cube, and here s minus 1 into s plus 1. So a into bracket s cube means s raised to 5. Okay, minus s cube. So this is coming because of this, because s square minus 1, and if you multiply by s cube, then you are getting s raised to 5 minus s cube plus b. For b, we can observe that it is s square. It is s square minus 1. So we are getting s raised to 4 minus s square. Okay, try to understand how to simplify this. S plus 1 and s minus 1 comes s square minus 1, therefore c. Then there is s, but this is s square minus 1. So here comes k and here s remains. Plus, now b is there. Okay, and this is, so b into bracket s square minus 1. And then observe that e is there. So e into bracket s raised to 4, this s raised to 5 plus s raised to 4. How? If you multiply inside the bracket, you are getting, okay, plus here last s raised to 5 minus s raised to 4. Okay. What we have to do? We have to calculate remaining. D, E, F we are getting, but A, B, C we have to find out. So this is what is the method. Now observe that s raised to 5 is there. Here we can observe that s raised to 5, and here also we can observe s raised to 5. So comparing coefficient of s raised to 5, comparing coefficients. Okay, we get. How to compare? 5, 5, 5. See, 5 means A. Here 5 means where? This one, plus E. Here 5 means plus F. And this is equated to left hand side. There is no s raised to 5. So I will write 0. This is 2. And therefore, A is equal to minus E minus F. That is, E is there, half. it will cut, and you are getting 0. So A is 0. So let me erase this thing. Sorry. Okay. Then I will compare S raised to 4. I will compare S raised to 4. There is B. Again. B. See what happens? If S raised to 4 is there B, then one more S raised to 4 you can observe 2 more. E plus and F minus. Why minus? Because S raised to 4 is negative and it is multiplied by F. But I can equate this to 0 because S raised to 4 is absent on left hand side. Very simple, but it's a lengthy problem. Then F is there, we shift, it becomes plus and it becomes negative. So B is equal to F. You can observe that F is minus half and A is also half. So this comes minus 1. Therefore, you directly write B is equal to minus 1. A is left, A is there, 0. B is minus 1, now C is left. To obtain C, we compare value of S. See, here S is there and no more S. So this is minus C. Also, minus C is equal to. Here we can observe that there is no yes, therefore we are at 0 and therefore we are getting 0. So A is 0, C is 0 and then what we get is B, E, D, F. So we can put the values and then we get the answer. Okay. So, okay. Let me erase these things now. Now I will put here. See, putting A, B, C, putting A, B, C, D, E, F in above. Above means this expression. Here I can write this as it is. This is 0. C is 0. Right? But B is not 0. B is minus 1. So I will write minus 1 over here. Okay. And then D. D means, yes, D is 1. So here I will write 1. Here E. We can observe that E is half. So I will write half. F. F is minus half. So I will replace this by minus half. Right? So finding ABCD in F, we are getting nice expression. Okay. Now, how to get inverse of Laplace transform? That's the problem. So at once this is ready, I will take inverse Laplace of this. Inverse into bracket twice is square minus 1. So this is what is y. Okay, this is what is y. So an inverse into bracket 0 y is I don't write. So minus 1 y square. Then here 0, I don't write this. So inverse into bracket 1 is equal to 4. Then half is there, we can take outside because it is constant. 1 upon s minus 1. Then here minus half outside, here inverse 1 upon s plus 1. So y is equal to, this is minus t, standard formula, s raised to 4. That means you have to tq by 3 factorial. How? It comes from standard formula. This is half. But it is 1 upon s minus 1. That is standard formula tells you it's e raised to t. And then minus 1 upon 2. It's the inverse Laplace transform e raised to minus t. That's the answer. It's quite a big problem, no? Okay. But so many things we can learn from this problem, right? Thank you.